Okay, then let's complete the denotational semantics of the simple programming language. Here I rewrite the definition of semantics using the lambda notation, and for while command it is defined as the least fixed point of the function as we discussed. The last thing I want to discuss in the lecture is a bit more general perspective. So far we have defined only the semantics of while as a fixed point. But in general, the semantics of all commands can be formalized as the least fixed point of a function. Okay. Here is a simple example. Let's consider the following function h that is defined using the two components f and g. So h of x comma y is a pair of fx and gy. Here are the definitions of f and g. F is just a constant function, so it is trivially compositional, like the semantics of some other commands, such as assignment, skip, and so on. But G is inductively defined, like the semantics of while, as you can see. Okay. Then what is the least fixed point of H? One might say that the least fixed point of H is a pair of 1 and the least fixed point of G. Okay, but we can use the notion of least fixed point for the constant function also, right? So generally, the least fixed point of H can be compositionally defined using that of each component f and g, like this. Okay, so here is my point. So generally the semantics of a program, not just for the semantics of while, is defined as the least fixed point of a function. Suppose a program P consists of subcommands C1 to Cn. Okay, then we can define this program P as a tuple of C1 to Cn. Okay. Then the semantics of program P is also defined as a composition of the semantics of each component, like this. Then some of the semantics will be simplified like this, A1 and AN, as we see the semantics of skip or assignment and so on. But for some other cases, like while, it will be inductively defined, so it cannot be directly simplified to atomic expression. So we need a definition using fixed point for this CI, like the while case. Okay, so here my point is that the same principle in the last slide is also applicable here. So even though some of them are already compositional definition, we can describe them as fixed point also. So the fixed point based definition is not just applicable to only while, but applicable to the semantics of whole program by introducing a more general function f that concerns the whole program. So as you can see the this tuple on the right hand side and the left hand side also. Then what is the semantics of this program? That is the least fixed point of this f. That is the tuple of C1 to Cn, which is the semantics of program P. So let me summarize this lecture. We have learned denotational semantics that describes mathematical meaning of programs. The semantics of program in denotational semantics is an element of a domain called CPO. Also, it is defined as the least fixed point of a continuous function f. Okay. One important property of denotational semantics is that the semantics is compositionally defined by that of each subcommand. And also the least fixed point is actually the least upper bound of the following chain. Okay, that is denotational semantics.